Hi everyone, let's review section 0.12 on solving inequalities. Again, we're skimming. Read my notes. So inequalities involve symbols like these. Strict inequalities, like is less than or is greater than, or weak inequalities, like is less than or equal to, or is greater than or equal to. Inequations involve this symbol. Now, when you're dealing with linear inequalities, you have to remember that we reverse the direction of an inequality sign if we switch sides or if we multiply or divide both sides by a negative number. So for example, if you're solving negative 3x is greater than x plus 8, well, you can subtract x from both sides. That's fine. You get negative 4x is greater than 8. But then when you divide both sides by negative 4, guess what happens? You have to flip the is greater than sign to an is less than sign. And then to write down the solution set, we want the set of all x in the reals such that x is less than negative 2. So the solution set consists of infinitely many real numbers. Here's the graph, all real numbers less than negative 2. Here's the interval form. Another way to do this is that you could subtract 8 and add 4x to both sides if you wanted a positive coefficient on x, but then when you switch sides, again, you have to flip the symbol. So in either method, you have to flip the symbol. 4x is less than negative 8, divide by positive 4, you get x is less than negative 2, and you end up with the same solution set. So in either method, you have to reverse that inequality symbol. When solving absolute value inequalities, it helps to think of the absolute value of x as the distance between x and 0 on the real number line. So for example, if we want all real values of x whose absolute value is less than 1, we want all values of x that are closer than 1 unit away from 0. I want all real values of x whose distance from 0 is less than 1. You can think of the absolute value of x as absolute x minus 0. Well, that's going to be this barbell here with open endpoints. To solve the absolute value of x is greater than 1, we want all real values of x that are further than 1 unit away from 0. So we want values of x that are far away from 0. We want the wings. The left wing over here and the right wing over here. We want the union of these two intervals, the wings. Numbers further away from 0 than the 1 and the negative 1. By the way, don't write something like this. You never put an inequality statement where you have the lesser number on the left, where you have the greater number on the left and the lesser number on the right where you have is less than symbols. Because really the values of x that satisfy this would be the empty set. Are there any real numbers greater than 1 and less than negative 1? No, that's garbage. So interval form is safest. Let's say you want to solve the absolute value of x minus 1 is less than 2. Well, you can think of this as u, like a substitution. If the absolute value of u is less than 2, that means that u itself has to be between negative 2 and positive 2. Add 1 to all three parts. We're allowed to do that. Negative 1 is less than x, and x is less than 3. There's an implied and here. It's a compound inequality. So the solution set is the set of all real values of x strictly between negative 1 and 3. The graph looks like this. Technically, you're supposed to put 0, but you don't have to. In interval form, we get this. We have infinitely many solutions in here. Another way to look at it, we can think of this as the distance between x and 1. So we want all real values of x that are closer than 2 units away from 1. Here's 1. 3 is 2 units greater than 1. -1 is 2 units less than 1. We want everything in between. You can think in terms of distances. And that's all.